The question is, let A be a 10 cross 10 matrix such that A power 5 is a null matrix, and let I be the 10 cross 10 identity matrix. The determinant of A plus I is. This question is from engineering mathematics from the topic linear algebra and the basics topic. Solution. So, A power 5 equal to 0. So, this is null matrix. A square, A cube, A power 4, A power any number is a null matrix. Such a matrix is called nilpotent matrix. Implies A is a nilpotent matrix. Implies, according to the properties of eigenvalues, all the eigenvalues of a nilpotent matrix are equal to 0. All the eigenvalues of A are equal to 0. Okay. Now, since A plus I is a polynomial matrix in A, MAT means matrix. Therefore, eigenvalues of matrix A plus I are equal to lambda plus 1, where lambda is the eigenvalue of matrix A. 1 is the eigenvalue of the corresponding identity matrix. So, therefore, that is implies lambda value, that is nothing but here 0. We got nilpotent matrix. A is nilpotent matrix. We prove. Implies E values, that is eigenvalues of matrix A plus I are 0 plus 1, 0 plus 1 to 10 times, because 10 by 10 matrix. So, a 10 by 10 matrix having 10 eigenvalues. It implies 1 comma 1 comma 1, so on 1 10 times. So, all the eigenvalues are equal to 1 of the matrix A plus I. Therefore, determinant of a matrix is nothing but product of eigenvalues of the matrix using the properties of eigenvalues. Product of all eigenvalues of matrix A plus I, which is nothing but 1 into so on 1 10 times. So, answer is 1. So, this is by properties of eigenvalues. Okay. So, the answer is 1. This is end of the question. The question is, suppose the probability that a coin toss shown head is P, small p, where 0 less than P less than 1. The coin is tossed repeatedly until the first head appears. The expected number of tosses required is 4 options ABCD given. Solution. So here, the probability P values lies between 0 to 1. If it is unbiased, getting head is 1 by 2. Biased, between 0 and 1. Okay, it may be more than half, less than half, we don't know. So until the first head appears. So expected number of tosses is also called average number of tosses to get the first head, that is mean. So getting head is given P. So we are denoting this is let small p given probability of head implies Q is equal to probability of tail. It is nothing but 1 minus, because probability of head plus probability of tail is equal to 1. In a single toss of a coin, biased or unbiased, whatever it may be. Okay, that is probability of success plus probability of failure is equal to 1. P of A plus P of A dash is equal to 1. Where A is an event taking that the outcome had happened, A dash is an event of getting the outcome tail. Now, this is a random variables related chapter. So this question is from engineering mathematics, from the topic probability and statistics, random variables, subtopic. Let X denote number of tosses required to get first head. That is one head. So this X is a random variable, which is a discrete random variable. That is X value taking one toss or two tosses or three tosses, endless. We don't know where it stops. So the distribution table is capital X is equal to small x, and this is probability of small x. So small x is the value of capital X. This is 1, 2, 3, so on. What is P of 1 means probability of getting head in the first toss, that is small p. What is P of X is equal to 2 means probability of getting head in the second toss, that is not getting head in the first toss. Okay. So that is nothing but Q into P. What is Q into P? Probability of getting tail in the first toss multiplied by probability of getting head in the second toss, first time. What is probability of X is equal to 3? Q, Q, P. That is probability of getting tail in the first toss, tail in the second toss, getting first time head in the third toss, etc. Where it gets, we don't know. So X is discrete random variable. I can write discrete random variable. So expected number of tosses required, REQ means required, E is nothing but E of X. So mean of X, summation X is equal to 1 to infinity X times probability of X. So 1 into probability of 1 is small p, 2 into probability of 2 is QP, 3 into probability of 3 is Q square P, plus so on. In all these, P is common into 1 plus 2Q plus 3Q square plus so on. So it looks like 1 plus 2x plus 3x square etc. 1 minus Q whole to the power minus 2. Since 1 plus 2x plus 3x square binomial expansions or Taylor series plus so on equal to 1 minus x whole to the power minus 2 if x values rise between minus 1 and 1, that is mod x less than. So this is p into 1 minus q is p, so p power minus 2, which simplifies to finally 1 upon 1 by p. Okay. So the answer is 1 upon p. Accordingly, the option is C. This is the end of the question. The question is, let f of x be a real valued function such that f dash x naught is equal to 0 for some x naught belongs to open interval 0 comma 1 and f double dash x greater than 0 for all x belongs to 0 comma 1 full stop. The f of x has four options A, B, C, D given. This question is from engineering mathematics from the topic differential calculus, maxima minima subtopic. The solution is so here this is the condition when first derivative equal to 0 means the values of x obtained from that condition are called stationary points and second derivative greater than 0 all x values belongs to the open interval 0 1 take care. So given f dash x naught is equal to 0 implies x naught is a stationary point of the function f of x and also given this x naught lies between 0 and 1 that is x naught belongs to 0 comma 1 open interval. Next, since f double dash x greater than 0 for all x belongs to open interval 0 comma 1 that means for every number x between 0 and 1 it's a second derivative greater than 0 x naught is one of the point belongs to 0 comma 1 okay. So there f double dash x naught greater than 0 as x naught belongs to open interval 0 comma 1. So when second derivative greater than 0, first derivative equal to 0, such a stationary point, you know that. Therefore, f of x has local minima at x naught. This belongs to 0 comma 1. So option A, no local minimum. So option A wrong. One local maximum in 0 1 because we have according to the condition 1 x naught is a stationary point. So option B wrong. Option C exact one local minimum. So almost it is correct. Option D two distinct local minima. We didn't get two stationary points. Okay. So since we have one STPT, that is ST means stationary, PT means point. Therefore, f of x has exactly one local minimum in open interval 0 comma 1. And moreover here given for some x naught belongs to 0 1. Some means it is 1 is the only stationary point you can write here directly. Okay. And you can write and some x naught belongs to 0 comma 1. Okay. That is the condition given here. So that is why we have one stationary point x fx's local. So accordingly, answer is option C. This is end of the question. The question is let P and Q be real numbers such that P square plus Q square is equal to 1. The eigenvalues of the matrix P, Q minus P are four options A, B, C, D given. This question is from engineering mathematics from the topic linear algebra subtopic eigenvalues. The solution is Now, P square plus Q square is equal to 1. This is given. Characteristic. So let us denote this matrix by A, capital A. Characteristic equation of matrix A is determinant A minus lambda I, that is P minus lambda Q minus P minus lambda. So determinant A B C D 2 by 2 matrix AD minus BC. I can write this is lambda square minus B square, product of these two diagonal elements minus product of non-diagonal elements equal to 0, which implies lambda square is equal to P square plus Q square. Shift the negative terms to the right side, which is given 1. P square plus Q square value 1, since by equation 1. So lambda is equal to plus or minus 1, square root of 1, 1. Before finding square root, put plus or minus 1. So therefore, lambda is equal to 1 and minus 1. Or the lambda is nothing but eigenvalue. Eigenvalues of the matrix, given matrix A. So the answer is 1 and minus 1. Accordingly, option C. This is end of the question. The question is, in the open interval 0, 1, the polynomial P of x is equal to x power 4 minus 4x cube plus 2. And 4 options ABCD given. This question is from engineering mathematics from the topic numerical methods. Solution. According to intermediate value theorem. Okay. So give one by one value for x, that is integer values. Start from 0, 1, 2, 3 one side, or minus 1, minus 2, minus 3 other side. Whenever two consecutive function values are of opposite signs, then the root lies between the corresponding abscissa, that is x values. X values are nothing but roots. Function values giving 0. Sometimes, depending on the situation, non-integer values, that is put x equal to 0.5, x is equal to 0.8, etc. So, P of 0. This is simplifies to 2, which is greater than 0. And P of 1, 1 minus 4 plus 2, that is minus 1. In the first two beginning function values, we are getting the opposite signs. So P of 0 and P of 1 are of opposite signs. Implies one real root lies between 0 and 1. And they are asking in the open interval. 2 real roots, 1 real root, 3 real roots, no real roots. So option D is wrong. We decide other option. So depending on the situation, you can find P of 0.5, P of 0.7, etc. But it is time taking 0.74 whole power. So let us use the Descartes rule of sign. So what is P of minus x? X equal to minus x power 4 plus 4x cube plus 2. Signs of P of x, that is symbols, coefficients of the terms, which are nothing but signs. X power 4 coefficient is plus, x cube coefficient is minus 4, and constant term is plus. So that is minus 4 means plus, minus symbol. Similarly, signs of P of minus x. Nothing but plus, plus, plus. Here no change. That means it has no negative real roots. Here there are two changes. It is having at most two positive roots. So that is called Descartes rule of sign. Some people read as Descartes rule of sign. So this is one change, plus 2 minus, and this is another change, minus 2 plus. So implies two sign changes combined. Two sign changes in P of X and no sign changes in P of minus X. Therefore, P of X has at most two positive roots. Roots means real roots automatic, and no negative roots. From this statement, don't decide two real roots or one real, because they are asking in 0, 1. Let us try the other integer value. After 1, put x is equal to p of 2, how much? 16 minus 4 into 8, 32 plus 2, which is, without simplifying, I can say less than 0. So p of 2, p of 1 less than 0, p of 2 less than 0, they are the two consecutive constant values are of same signs. We cannot decide. P of 3, e power 4, 81, g cube 27 into 4, 108, plus still it is less than 0. Let us try one more value, positive value. If you are getting still continuously all are of same sign, then backtracking, that is finding p of minus 1, p of minus 2, go on giving negative values of x. P of 4, put x is equal to 4, 4 power 4, 16 into 16, 256, minus 4 cube into 4, that is again 4 power 4, 256, plus is greater than 0. So that means P of 3 and P of 4 are of opposite signs. Implies one real root lies between 3 and 4. So from the last statement, this one and at most two positive roots, and this one, what is the conclusion? Automatically C. Hence, in the 0, 1, but the other root lies between 3 and 2. P of x, the polynomial P of x has one real root. So the answer is one real root. Accordingly, the option is C. This is the end of the question. The question is, suppose the circle x square plus y square is equal to 1. So this is x square, typing error. And x minus 1 whole square plus y minus 1 whole square is equal to r square intersect each other orthogonally at the point u comma b. Then u plus v is equal to. This question is from engineering mathematics, from the topic calculus, either differentiation calculus, product of the slopes minus 1, or you can use vector calculus, that is grad phi dot grad psi is equal to 0, each is denoted by phi and psi, curves are surfaces. The solution is, let phi is equal to x square plus y square minus 1 is equal to 0, and psi, that is psi of x comma x minus 1 square plus y minus 1 whole square minus r square is equal to 0. So all of it, this is equation 1 and this is equation 2. So del phi. These are two variables. I cap dou phi by dou x plus j cap dou phi by dou y is equal to x square derivative partially with respect to x is 2x. Similarly, y square 2y with respect to y. So 2x I cap with respect to y partially is giving 2y into j cap. Similarly, del psi grad psi is equal to I cap dou psi by dou x plus j cap dou psi by dou y. So partially with respect to x, psi function 2 into x minus 1. Partially with respect to y, we will be getting 2 into y minus 1. So 2 into x minus 1 I cap plus 2 into y minus 1 j cap. For intersecting or to intersect each other orthogonally. For intersecting orthogonally, that is the angle between the two curves makes 90 degrees. We have, according to vector calculus, approaching or normal differentiation method also, you will be getting del phi dot del psi is equal to 0, which implies so 2 into 2, that is here 4x into, dot product between two vectors. Product of the, that means sum of the products of the corresponding elements. That is I bar coefficient into I bar coefficient plus J bar coefficient into J bar coefficient plus 4 into y into y minus 1 is equal to 4 is taken common, 0 by 4 is 0. This simplifies to x square plus y square, shift the negative terms to the right side. Okay. Now, this u comma b is the point of intersection of the two curves. Am I correct or not? So, you can substitute here directly. At u comma b intersecting at the point, you will be getting 2u I cap plus 2v j cap. So, similarly, at this u comma v, you will be getting 2 into u minus 1 I cap plus 2 into v minus 1 j cap. So, now instead of this, you will be getting directly x is replaced by u, y is replaced by v, u square plus v square is equal to u plus already given, that is this value 1. Why? When two curves intersecting at a point, such point lies on each curve. So this becomes u plus v is equal to 1, since u comma v point lies on circle 1, implies you will be getting u square point satisfying the circle equation. This is the reason. Okay. So what I am suggesting, this is u square plus v square value. Okay. So the answer is 1. Second method, normal differentiation method, that is total derivative from the partial derivatives. I am using some other color. Let f of x comma y, two variables function, is equal to x square plus y square. That value is already given equation 1. And another function instead of phi and psi, g of x comma y is equal to x minus 1 whole square plus y minus 1 whole square is equal to r square. Equation 2. Okay. So, in this you will be getting dy by dx. So, minus, according to partial derivatives, ordinary derivative procedure, minus dou f by dou x divided by dou f by dou y. So, partial derivative with respect to x is 2x, with respect to y is, so you will be getting minus x by y. So, let us denote this is slope m1 is slope of curve 1, that is slope of the tangent to the curve 1, and dy by dx, slope of the tangent to the curve, that is to the circle 2, usually denoted by m2, is also from the partial derivatives. This is dou g by dou x divided by dou g by dou y. Dou g by dou x divided by dou g by dou y. So this is minus 2 into x minus 1 divided by 2 into y minus. Easy partial derivatives. 2 cancel, minus of x minus 1 divided by y minus. So, since intersecting orthogonally, that means product of the slopes is equal to minus m1 into m2 is equal to minus 1. That is from applications of derivatives from 11th class standard. Implies minus into minus plus x into x minus 1 divided by y into y minus 1. You will be getting minus 1. This simplifies to x square plus y square is equal to x plus. So, that is, this is already given 1. So, which implies x plus y is equal to 1. So, that means u plus v is equal to 1. Because u comma v is the point of intersection. That should have. So, since u comma v is point of intersection. So, that means you can find these m1, m2 slopes at u comma v. That is automatically uv lies on the two curves and then it has to satisfy the slopes. I mean, it is not me. It doesn't mean the satisfying the slope. We are calculating the slopes at u comma v point. Okay. Then right here minus u by v. You can write here at u comma v. You'll be getting the slope minus of 2 minus 1 divided by b minus. Finally, you'll be getting like this. So the answer is u plus v is equal to 1. This is the end of the question. The question is, let minus 1 minus j, comma 3 minus j, comma 3 plus j, and minus 1 plus j be the vertices of a rectangle C in the complex plane. Assuming that C is traversed in counterclockwise direction, comma, the value of the contour integral over C dz by z square into z minus 4 is 4 options A, B, C, D given. This question is from engineering mathematics from the topic complex variable, subtopic complex integration. The solution is so here rectangle is a closed curve. So the closed curve integrations which are easily evaluated by Cauchy's theorem, Cauchy integral theorem or Cauchy integral formula. If more than one singular points, it is better suggestion to apply Cauchy's residue theorem. Let us see. Now, let A, that is minus 1 minus j, which is nothing but minus 1 comma minus 1 in 2D geometry representation. B is equal to 3 minus j, which is nothing but 3 comma minus 1 in coordinate geometry. C is equal to 3 plus j, nothing but 3 comma 1. I mean, better C is already given curve. Let us take this is another coordinate name, vertex name. Rectangle has 4 vertices. I am taking the third vertex D, that is 3 plus j. And E is equal to minus 1 plus j. Is nothing but minus 1 comma 1. Be the vertices of a rectangle C. This is closed curve. Now the diagram. So x minimum -1, maximum 3. Y minimum -1, maximum 1. Axis, y axis, origin. So to say -1, and this is 1, 2, 3. 1, 2. So now what are the vertices name? A, B, D. A -1 comma -1. X value -1, Y value -1. So this is the point E. B 3 comma -1. X value 3, Y value -1. So this is, let us approximately E 3 comma 1. So this is E. E -1 comma 1. X value -1, Y value 1. Now join these four vertices by the straight lines, that is rectangle. You will be getting this is the rough sketch of the diagram. Rectangle. Okay. So this is C direction, anti-clockwise, that is counterclockwise. Now, first find the singularities. Z square into equating denominator of the given integrand to 0. You will be getting Z is equal to 0, comma 4. Of course, 0 is a repeated point. Or the singular points. Singular point short form written as SP. Now 0 means 0 comma 0. So this is the point. 4 means x value 4, y value 0. There is j part. Imaginary part is absent. Here j is nothing but root -1. So I will denote that singular points by black color dots. 0, this one is 0, and other one is 4. So this is maximum 3, and this is 1. This is -1, and this is -1. So 4 is beyond the curve. That is 4 is lies outside the curve. Okay. So this is inside C, and this is outside C. Okay. So one point inside C, other point outside C. So this is a both types problem. One is inside, other is outside. Mixed case. I can adjust the given integrand as integral over C dz by z square into z minus 4. So the factor, that is the singular point 4, corresponds to the factor z minus 4, which is outside. So just write this factor in the numerator, remaining in the denominator. So it can be adjusted as 1 by z minus 4 in brackets, whole divided by z square can be written as z minus 0 whole square, where the singular point, the corresponding factor should keep in the numerator. Such a singular point usually denoted by small a. Now the numerator is denoted by f of z. It looks like Cauchy's integral formula f of z by z minus a whole square. That is answer 2 pi I by 1 factorial into f dash a. A means 0. Okay. Or some people written as this is 2 pi I by 1 factorial derivative with respect to z of the numerator function 1 by z minus 4. After that, substituting at z is equal to 0. So since by Cauchy's integral formula. So this is 2 pi I. Here f dash 0 means this is f of z, after that derivative and then z is equal to 0. So 1 by z minus 4 derivative is minus 1 by z minus 4 square, and then put at z is equal to 0. This vertical line indicates x, that is substituting that point z0. So 2 pi I with minus 4 whole square means 60. Finally this simplifies to minus. Of course, we already used in that question. In the question, all the vertices by j notation. So it is better replaced by j in place of I. Kindly excuse me. So this is j, 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 j. So 2 pi j here also 2 pi j, 2 pi j minus 2 pi j. So finally minus pi j divided by 8. So the answer is minus j pi by 8. Accordingly, the option is B. This is end of the question.